For this video, I'm returning back to a two-dimensional array that I had created for tracking student ID numbers. And if you recall, if you've seen this video, there's a for loop that we used in order to traverse through that whole list of ID numbers so we could print it. If you remember, there's a for loop inside a for loop. The first for loop is really running through each row, and the second for loop really checks each column in the array. Now, if we wanted to just cycle through the entire array and we just want to see every element in the two-dimensional array, we don't care about formatting and just want to cycle through every element. Maybe we want to do something to every element in the array, or we just want to access every element in the array. We could use a for each loop. And so I'm going to leave the output there from this previous for loop. So we know that that is going to print what is seen here in my output window. It's going to print a very nice, I guess, visual table of the student ID numbers. But in order to kind of do the for each loop here, remember we're going to use the for loop. And this time what I want to do is I want to cycle through every row in my column. And of course, these are all integers, the index numbers. So I'm going to go int row for each row, for each integer row in my ID numbers array. Okay, so for each integer row in my ID numbers array, okay, I am going to now look at each element in that row. And so I'm going to do another for loop for each integer element in that row. And what I want to do is I'm going to want to print out the element that I'm looking at, like that. So it's the main structure that I'm looking at, and of course when you ever see an error you can look at what's going on. And so it says incompatible types, found integer. Now the issue here is that I have to remember the row column idea, because currently with what I have on the screen I haven't treated this like a two-dimensional array. I've actually really treated this like a one-dimensional array. So we have to remember that this, I have to say look at each row. So if you remember correctly, I kind of have to have set here. When we did the for each loop, you have to remember it's kind of tricky because we had to throw this in here because we were trying to count which row we were in. Remember, I was the row tracker here. But this says, hey, okay, remember we have row by column, so each integer row is tracked by the first set of brackets. So for each integer row in ID numbers, okay, we want to cycle through for each element in that row. And an element, by the way, remember an element is a technical integer. It is an integer here, where a row is not an integer. It's a row, so I need to access that. So this will now print me another list of my ID numbers, and there you go. It cycles through and prints every element. Now I know we liked the table up here with this kind of loop, with a standard for loop. We built a little table. That's actually quite a bit harder to do here with a for each loop. For each loop is really designed to just cycle through every element in the array and then to either access to print it or access it to do something to it, to add something to it. So we could, for example, here, I could take this output statement, throw it inside this for loop, which is really where it was before. That's not any surprise. That's nothing new. But maybe this time before I print it, maybe I take that element and I add, just so we can make this obvious, I will add 3. We'll add, let's see there, we need 6 digits, 7 digits. So all of our ID numbers are 7 digits. I'll add that 1 million there. So we'll add 1 million to every element before we print it. And we can do that. That'll just access every element, and when it sees it, it'll add 1 million, and we'll run our output, and you can see that every ID number now starts with 3 instead of 2. That's all good. One word of caution here: if I were to go back now that I have added 1 million to every element, and I were to print the array again, I'm going to cut that print statement out, and I'm now going to access everything and print it after I've run that add 1 million to every. And if I run this, now it will print twice. It'll print the table second. And when I look at it, there's one thing that's very important that you have to understand here, that for each loop did not permanently change my numbers in my array. So if you see here, the first for loop added 1 million, so they all start with 3. But after I did that for each loop, and then I print the actual array again, it actually went back to 2 million. And so we have to remember that the for each loop isn't really changing the array at all. It's just accessing the array. Now if we want to change it, we can change it by what we did here. We can change the numbers before they're output in. But it doesn't actually change permanently in memory. And so that's actually quite important to remember. Where if I go down here to a standard for loop, down in my standard for loop, if I were to change this statement right here, let's see what happens. I go in here, and before I print this in a standard for loop, now I take ID numbers I, J, and I add 1 million to that before I print it. Okay, I'll run that, I'll print it, and that's all good. So I see I'm getting my 3s here as my first digit. If I take now this for each loop and I add that output statement here at the end instead of the beginning, and I run this, you'll see now that all of my digits start with 4s. All of my ID numbers start with 4s, and that's because this standard for loop did permanently change all the numbers in the array, and then this for each loop added another 1 million and made them 4s. So that for each loop just cycles through and accesses the memory. It doesn't actually change the memory, so that's actually quite important to remember.